All right, so this is question 8. Frictional wedges, section 8.1. So John is trying to split a circular piece of wood using a 30-degree wedge and a hammer. When he hits the wedge with 200 newtons of force, the wedge gets stuck in the wood. The coefficient of static friction between the wood and the wedge is 0.7. What is the magnitude of forces exerted by the wedge as it gets stuck? So, I already have taken the liberty of drawing out our the diagram of the wood and the wedge getting hit and stuck in. So, right now though, what we are looking at and what we should do is we're going to create a free body diagram of the wedge itself. So there's our wedge. Now keep in mind, this is before it gets stuck. This is before it gets stuck in the wood. So here we already know that this angle is 30 degrees. So we know that's 30 degrees. However, we're going to split it in half, as we're going to end up working with forces coming from both sides. So that means it's going to be 30 divided by 2, which gets me 15 degrees for each of those angles down there. So now that we have those, we can actually start moving on and working on the rest of this. So we have our we can draw in our horizontal. We draw in some horizontal lines coming in of where the wood will end up getting stuck into the wedge. However, it is not there yet. Right now, the wood is still going to be applying a force at an angle. And we'll call it R sub 1 and R sub 2. Now, along with that, we also have a force of 200 coming down into it. Which then means that we have to start figuring out what this angle is. Now, it's going to be the same as the opposite side, so I'm just going to write that angle there. And now I'm going to split this side into 2 parts. Now, we can look and infer that this angle here is going to be the same as this angle here, and call it 15 degrees. But now we need to figure out this one, this angle right here, which we'll call phi sub s, because it's going to be the force at which the friction is being applied and coming in. So as a result, we know that that's our friction, which means that this here, this angle right here, or the total angle between the two, between 15 and phi sub s, is going to equal, is going to be phi plus 15 degrees. So now we have to start solving for phi. So we know phi is has to do with the static coefficient and is the friction of that. So given that, we get tan of phi sub s equals what our static friction coefficient is. So now, but now we're going to take the inverse tan of that, so that way we can get our phi value. So inverse tan of 0.7 equals our phi value. So when you do this out, you're going to get phi is approximately 35 degrees. So now what we're going to do is we're going to solve for this angle right here. So we know that that angle is going to be 15 plus phi sub s. So this equals 15 plus 35. And when I add those two values up, I'm going to get 50 degrees. So now what we're going to do is we're going to work on creating our force triangle. So when we go for that, keep in mind this is still before it gets stuck in the wood. We're going to have a force of 200 newtons getting applied downwards. We're going to have our R sub 1 force and our R sub 2 force there. So we know that this is right here. It's going to be 200 down. Here we know this is R sub 1, and we know this is R sub 2. Now what we're going to do, though, is we're going to take this and split it, because we're going to split it horizontally at halfway. So given this, that means that this height here that was 200 is going to be actually 200 divided by 2, which gives me a force of 100 in just this shaded triangle, the triangle shaded blue. And now I also know that this angle here in the triangle that's shaded blue, this angle right here is going to be 50 degrees, because that is the angle at which R sub 1 comes in from the x-axis. That looks like 550 degrees. So given this, we can actually use, we can actually try to solve for our R sub 1 value. So when we're given this, we're not actually looking for R sub 1. We know this, but we actually want to find this area here. I'll color it in purple, but it's right here. We want to find the overall force in that x direction that's created that then gives us a resultant. So when we do this, we're actually going to take our tangent of 50, because we're going to want because we don't know R sub 1, so we're going to want to use our tangent. So we're going to do tan of 50 equals our opposite. So in this case, we know it's 100 divided by our same side, which we don't know. So I'm going to call it x. So now I'm going to rewrite this. So I'm going to multiply x to the other side. So now it's x tan 50 equals 100. I'm going to divide both sides by tangent of 50. And when I do that, I'll get x equals 83.9 newtons. And that would be the force when the wedge gets stuck and the wood now is applying forces horizontally. While before we were calculating out for when it was like this, the wedge then gets driven in. So it starts off like this with forces coming in like this. The wedge then gets driven into the wood, causing the forces to come in like this now on it. And we just solved for that. We just figured out what our x value is for that. So if I was to redraw my free body diagram for the wedge now that it's stuck, it would actually look like this. So there's that. We're going to still have this here will be 30 still. Yes, and we could split it back up again, but I'm just going to leave it like that. And we now have forces coming in horizontally still. We have forces coming in horizontally, and each of these are just going to be x value, or x value. And then, of course, you still have the angle from here. And this angle here is going to be the 15. Not 50, sorry, the 15 degrees. And therefore, the magnitude of forces when the wedge gets stuck, because after the wedge is stuck, there's no longer that force driving down. There's no vertical force. There's just horizontal forces. So as a result, the magnitude of force would be the square root of 83.9 squared, which then equals just our 83.9. So, and that is the magnitude of forces on the wedge after it gets stuck. Thank you.